Ladies and gentlemen, welcome back to math class. Today it's Unit 9, Day 4. We're going to classify some polygons. And the first thing we need to know is what a polygon is. So a polygon is a closed plane figure formed by 3 or more segments. Let's take a look at each one of these words here. Closed. So this would not be a closed figure. However, this is a closed figure. So that's what closed means. Plane means it's two-dimensional. It lies on a piece of paper here, like a plane, as opposed to being three-dimensional, like the screwdriver is a three-dimensional object. So that's the plane part. Formed by 3 or more segments. 3. That means this cannot be a polygon, but this one could be a polygon because it has 1, 2, 3 segments. This could be a polygon because it has more than 3 segments. 1, 2, 3, 4, 5, 6, 7. This could be a polygon. Segments. It's the word segment as opposed to the word line. So we would not call these lines. We wouldn't say this polygon is made up of 4 lines. We would say it's made up of 4 segments. Remember, segments start at a point and end at a point. So we'd start at a point and end at a point. Start at a point, end at a point. Start and end, and start and end. So each one of these is a segment. Each one of these is a segment. And each one of these is a segment. So they're segments and not lines. Now polygons are named by their number of sides. Triangle has 3 sides. Nice example. A quadrilateral has 4 sides. 1, 2, 3, 4. Pentagon has 5 sides. You can think of the pentagon, the government facility is a pentagon. I should have said qua, like in quarter, quadrilateral for 4, and tri means 3, triangle. Hex, your guess is as good as mine. I always remembered the hex because there's an X in the word 6, and there's an X in the hexagon, so that's what I used to remember it when I was your age. A heptagon, boy, let's see, 1, 2, 3, 4, 5, 6, 7. You're just going to have to remember that one. I don't have any good advice for you on that one. And an octagon, the classic example is the stop sign. I think I just messed up my octagon. Example 1, 2, 3, 4, 5, 6, 7, 8. Octagon has 8 sides. And so to take this further, an entagon would have n sides. So if we had something that was 9 sides, it would be a nonagon, and so it would have 9 sides. How we name polygons? By the number of sides that they have. So one of the things we want to do with the polygons is we want to be able to find the sum of the angles on the inside of a polygon. So what we can do is use what we already know about triangles. Here's an example from the other day. Just a plain old triangle. And we know that if we add up the interior angles of the triangle, it will always equal 180 degrees. Remember, these equaled 180 degrees. We know that. Let's keep that in the back of our mind. So how are we going to use that to find the sum of the angles in polygons? Well, I've got to start here. Oh, there goes the camera. I've got a plain old quadrilateral. I've got a four-sided polygon. And right now you're thinking, well, you know what? That doesn't help me a lot with the triangles because that's a 3-sided figure. And clearly I have a 4-sided figure. But what if I took my pencil, and I don't know if you can see that. Nope, you can't. So what if I took a marker and I drew a line and cut my quadrilateral into 2 triangles? That's okay, no problems with that. In fact, let me zoom in. Now I have 2 triangles, right? Well, the sum of the angles of a triangle adds up to 180 degrees, so the sum of all the angles in this triangle will equal 180 degrees. And the sum of all the angles in this triangle will also equal 180 degrees. So 180 degrees plus 180 equals 360 degrees. Okay, well, I believe you so far, Mrs. Pritchard, but what about this odd-shaped quadrilateral? It's got 4 sides, it's a quadrilateral. Can I still cut this one into triangles? Well, the answer is yes. So all I have to do is take and bisect it and cut it into 2 triangles. All of these angles, this one, and that one, will still add up to be 180, just like it did up here. And all of these, I'll double those up, all of those will equal 180 as well. So then we have 180 still, this 180, plus this 180, gives me 360 degrees. Let me give you one more example with a 5-sided figure, the pentagon. I've drawn a pentagon, and I've picked one corner, and I've drawn a straight line to an opposing vertice to make a triangle. Then I've done it again to the other vertice. Now, if I draw a line here, I'm not really creating a triangle, so it doesn't do me any good to draw a line there. Same for this side right here. So the most I can draw is 1, 2, 3 triangles. The interior angles of this triangle, we'll call it 1, is 180. We'll call this triangle 2. It has 180 degrees interior angles. And we'll call this little guy here 3. He also has 180 degrees total. So if we add those all up, we have 0, 4, 2, carry the 1, so 540 degrees. The interior angles of a pentagon, a 5-sided figure, equal 540 degrees. So anytime you have a polygon, you can pick one corner, draw a straight line to a vertice to create a triangle, and do that with all the other vertices that are not directly connected to the point that you're starting from, and create triangles, and total up the interior angles for each one of those triangles, and that's how you will get the sum of all of the angles in the pentagon, or any quadrilateral, actually any polygon. A regular polygon is a polygon that has sides of equal length and angles of equal measure. That means all of the angles have exactly the same measurement and all the sides are exactly the same length. These 2 polygons right here, the top one is 1, 2, 3, 4, 5, 6, 7, and 8-sided polygon, an octagon. All of its sides are the same length, all of its angles have the same measure. The bottom is a heptagon, 7 equal sides, 7 equal angles. How's that differ from a non-regular polygon? Number 16 is not a regular polygon. It's a quadrilateral, 4-sided figure, but you can see that all of the angles are not the same, and clearly all of the side lengths are not the same. And 18 is a non-regular pentagon. Obviously, the sides are not the same length, and the angles are not the same measure. So, regular and non-regular polygons. Okay, so here's a little graphic organizer of quadrilaterals, and they're a polygon, a 4-sided polygon, and they have lots of special little properties, and so they kind of have special names, some of them do. So, quadrilaterals is a category of the entire sheet. So the entire sheet is 4-sided figures. A portion of the 4-sided figures are trapezoids, and they have exactly 1 pair of parallel sides. Like this side and that side is parallel, and that one are parallel. So they have only 1 pair of parallel sides, which makes them different from the parallelograms that have two pairs of parallel sides. So all of the figures inside the parallelogram have two sets of parallel lines. Rectangles have four right angles. Squares have four congruent sides and four right angles, so a square can be a rectangle. A rhombus has four congruent sides, so a square could also be a rhombus, but the rhombus does not have to have right angles. So if you want to copy this in your notes, this is a nice little graphic organizer. There's also a copy in your textbook. This is exactly where I got it, and it's just a little handy thing to have in your notes. The quiz. What's tomorrow's quiz going to be on? Well, I'll tell you what. On tomorrow's quiz, I'm going to ask you to do two things for me. I'm going to ask you to name two different polygons. Doesn't matter to me which polygon you pick, but I want you to tell me two of them. And then, quadrilaterals, I'm going to have you tell me two different quadrilaterals. So, two polygons, and then two quadrilaterals for tomorrow's quiz. See you then. Bye-bye.